All right, page 12. Two more examples for area between two curves. Next section will be volumes when we start whipping things around axes and making cool, funky solids. So we'll wrap up area, then move on into volume. It takes us about, I don't know, we'll probably test late next week. There's only 3 sections we have to do. This is 7-1 in your book, and this is actually books number 74. So our worksheet only had one like this, and a lot of you had a question mark by it, so you tried it. So I thought this would be a good one to review. So we're going to set up and evaluate the definite integral. Remember, a definite integral has your limits going from a to b, and indefinite is just an antiderivative. So we're going to set up an integral that'll give us the area of the region bound by a cubic and a tangent line to the cubic. So let's pretend we don't have a calculator first, and then we'll go to the calculator. So I would put this one on that big white slice I gave you because there's not enough room in that space. You might want to write big slice on here in the space given in your packet, and then go put it on the big slice and just tuck it in. That's why I gave you the big slice of paper. I don't think you can fit this one or the other one in this space given in your packet. So first thing we're going to do is see if we could figure out how to graph it without a graphing calculator. So we know the cubic shape makes this or this, right? So I told you the easiest thing to do is to factor it to figure out where you're hitting the x-axis. And so we'll go do that right up on the top here. We'd have x times x squared minus 2. If I had to do it by hand, I don't need to get it super accurate. I just need kind of a good flow of the graph. So this would have an x-axis hit at 0. And at the square root of 2, so let's go over here. Square root of 2 is like 1.4-ish. And at negative square root of 2. And then I need to know end behavior, so I know where to swoop in and hit those from. And we talked about that in the last section of notes, that you kind of pretend you're coming in from negative infinity, and this would be negative. So you're coming in, doesn't really matter how high or low you get, but you kind of boom. And then I'd like you to go put it on your graphing calculator to back that up. All right, so we'll go enter x cubed minus 2x on your graphing calculator and go ahead and graph it. I've got it logged back here on my smart view. I'll move it into viewing screen. So I've also got another one on there. You might as well go enter both of them, but we've got to figure out why I put that other one on there. Enter x cubed minus 2x first, and go ahead and hit graph, and so mine will be the first one we see. I think I need to zoom. I think I'll zoom 6. Get a little nicer viewing window here. Sorry. Let's zoom 6. There we go. And it's going to be kind of tiny in there. And then I think I'm going to zoom out just to mess around with my viewing window. That's the line we're going to go find in just a second. I already just did it ahead of time. So I'm going to zoom and I'm going to zoom out. So let's get a decent picture of that. All right. Whoa. Huh. I wanted to zoom in. Dang it. Why would I zoom out? That's dumb of me. Anyway, now it has a delay on my stupid smartboard too. So now I'm going to have to zoom in, I think, twice. If you keep entering it, I think it'll just keep zooming. Will it go again if I do it one more time? While you're waiting, and now mine's wigging out on me, so I'm going to move it off to the side here. Come on, baby. Why? No. Why won't it even go here? There. All right. Anyway, back to the original. So this is our original graph. It's good enough for our purposes. We also need to graph the tangent line to the curve. So we need to nick the curve at negative 1, 1. So I need the tangent line. It's going to be going like that I mean, I can kind of tell, but I need an equation for it because I need to do top function minus bottom function. So I know that my shading is going to happen in here because it's the area enclosed by the two curves. So you can take out either a highlighter, colored pencil, I don't care what you use, but it's nice to shade in that region, and you should do that on your homework. I always graph and then shade. So, I need to go figure out what the equation is of that blue line. So here's what I've got going. I know it goes through the point negative 1, 1. So I would say y minus the y I know is equal to the slope there times x minus the x I know. So the only thing I need is the slope of this tangent line. And a slope of a tangent line is the derivative. So what I need to go do is find the derivative to the curve at that point. So I'm going to go back up to my, let's write this down, my original function. I'm going to take the derivative, which would be 3x squared minus 2. All right, so my 3x squared minus 2 will give me the slope of the tangent line everywhere on the curve. I want it at negative 1, 1. So a lot of times you'll see it written like this. The derivative at, and then they'll put the point right here. That's kind of good notation, actually. My derivative is only dependent upon x. It's not implicit, it's explicit. So all I need to do is, we've done this a lot, go plug this in, and I get a 1. So I go back up here. And now to graph it, you should solve it for y. So I've got y equals, let's go back up here, it'd be x plus 1 plus 1. So I'll add that 1 right there over to the other side. So my line is y equals x plus 2, and you should go graph that on your graphing calculator as well so you can see that nice nicking of it. I'm not going to go do that. So I need to find the area between the two curves. So your general formula is that you integrate, and I need to make a decision, vertical or horizontal. Who's the go-to? Who do you always try first? Vertical, go pretend you're coloring vertically along here, and if at any point you have a difficulty or the top and the bottom function switch, then try horizontal, but this is set up beautifully for vertical. The blue is always on the top, or the line is, and the curve is always on the bottom, and we go top minus bottom, so this is nice. I just kind of need to know where this is. Where do you think it looks like, just even based on our cheesy graph? It looks like it's 2 over. So what you should do is kind of take a look and see on the line and on the curve what happens when you put a 2 in. And if you get the same answer, it's going to be the same. So on the line, it'd be 2, 4, and on the curve, it'd be 8 minus 4, it's 2, 4. So I don't even really need a calc intersect or any algebra. I can kind of just get it off a decent graph. So I'm going to integrate and color from negative 1 on the x-axis to 2 on the x-axis. Top function, which is the line, so I'm going to have x plus 2 minus bottom function, which is the curve, which was x cubed minus 2x dx. So I've got top function minus bottom function, and that's what I should need to integrate. So let's go do that by hand even. Whoa, that's going to be tons of fun. All right, so I'm going to clean up that integrand, go from negative 1 to 2. I've got a negative x cubed right there. I've got a plus 2x and another x. So it looks like I have a plus 3x, right? Check my arithmetic because that's where I tend to goof up. But I've got the negative x cubed plus 2x, and then I have a plus 2. All right, any mistakes made yet, or am I good? I'm good? All right, so let's go do the antiderivative by hand, just to, because we haven't for a while. We've been going to our calculator. It'd be negative x to the 4th over 4 plus 3x squared over 2 plus 2x evaluated from negative 1 up to 2. Fundamental theorem of calculus. Top goes in first, so let's go dump that in. By the way, it's not negative x to the 4th. It's negative x to the 4th, and there's a difference. So that's going to be a negative 16 over 4, so negative 4, plus 3 times 2 squared, or 12 over 2, which will be 6, plus 4. Am I still good? Watch my arithmetic. I think I'm good. Make sure you go minus. Make sure you put brackets so that you don't make any sign errors. Negative 1 to the fourth is 1, but there's this negative out front, so I'm going to have negative 1/4. Then this will be what? 3/2. Whew, minus 2. This is my least favorite part of integrating is by hand fraction stuff. So let's just be really careful. My 4's are going to disappear. All right. Have I made any mistakes yet? Do you see one? Those of you good at arithmetic? Am I good so far? So let's see. If I clean this all up, I've got 6 plus 1/4 because of this, minus 3/2. I'm distributing the negative in, plus 2. Yes. I put in a negative 1 right there. So I'm still good, I think. And now I've distributed. So I've got an 8. Lovely. An 8. And then I've got plus 1/4 minus 3/2. At this point, I'd probably go to a nice common denominator. Something doesn't seem right, but I think it's good. So let's see. My common denominator is a 4. So I would have what? 32 over 4 plus 1 over 4 minus 8 over, no, 6 over 4. Yes. Arithmetic nightmare. So what do I end up with there? I'm at 33, 27/4. Lovely. When would you ever choose to do that by hand? Only when you don't have a calculator. But that will happen sometimes. And I haven't cranked one out for a long time because I hate all the arithmetic. But we should be pretty good at it. So that's that one. The last one we're going to do, and then we're just going to work on the assignment. Last one will be this one. I would suggest you color code yours. You don't have to do it like mine is in red and green and blue. Maybe do yours in 3 different colors just so you can kind of see what's going on with this one. So last one, we've got, first of all, functions given in terms of x, and that is a red light that you should kind of stop for a second and think about that. When they say x equals 9 out of 10 times, it means you're going to do horizontal coloring. Not always, but if it wasn't graphed, you would have to solve it for y to graph it anyway. But here's how we make our decision on how we're going to color it. So I've got green going down here, pick some color, and I've got red going here, and then I've got blue going here. And if I try to color vertically, watch what's going to happen here. Don't do it because it's going to make a mess, but I'll have blue minus green, blue minus green, blue minus green, blue minus green, blue minus green up to here, and then it switches to red minus green. And usually if you can avoid 2 integrals, that's the best thing. So I'm going to choose to color the other way because this over on the right, in terms of x, this is 3 minus y squared all over here. I can consider it one color because it is one, it's actually not a function, relation. So I'm going to actually color from the bottom up. And so let's make one representative rectangle right in the middle. Take one and make it nice and dark. Your base of your rectangles is dy, or this tiny little change on the y-axis. So this is what I'm going to have. Before I start, let's go kind of set it up. I'm going to be integrating from, but I'm going to color up the screen. So I'm going to be going from y up to y. So my boundary down here for y, it's going to go from -2, and I'm going to color this way up to 1. Then I need right function minus left. Understand why we do that? The right function will give me the x this far. The left function will give me x this far, so when I subtract them, I get the length of the rectangle. It's a lovely thing. So right function would be 3 minus y squared. Left function would be y plus 1, and we would do dy. I want you to go math 9 that. I'm not going to go through the fraction ickiness of it. make sure you're able to, but go math 9 that on your calculator, because then I'm going to show you the setup for vertical and we'll get the same answer. And then that's all we'll do today. So if you go math 9 that thing, I'll steal an answer. It wouldn't be a hard one to do the antiderivative of by hand, but let me steal a good. I'm getting 4.5. All right, so 4.5 is the answer, or 9/2 if we were to do it by hand. Let's put that in a box. Now let's see if you could figure out how to set it up if we did it vertically. All right, so first of all, vertically, I would be coloring like this from -1 out to here, which is at 3, I believe. But let's go see if we can do that. Go split your paper maybe like this. This is with horizontal representation. And again, the kicker to that is when it says x equals, that's generally a given. But if we were going to do vertical, let's set it up and then go to our calculator and see how that would go. I would integrate from, now I'm going to color this way, from -1 all the way over to right there. All right, and that's when y is 0, so x would be 3. So I'm going to go from -1 to 3. Now, I have to do everything in terms of x, right? So instead of x equals 3 minus y squared, I can't put 3 minus y squared in there. I need to solve it, all right? So let's go on the top and get our everything all done here, which if it hadn't been graphed for you, you would have to do this anyway. So let's solve it for y in terms of x. So we're going to add the y squared over to the left, subtract the x from the right, and we get two separate pieces on my graph. They're the red and they're the green. So plus or minus 3 minus x. So kind of know that. This up here, my red portion, go point at it, is root 3 minus x. This down here, my green portion, is negative root 3 minus x. And the line, when I solve it, is easy. Y is equal to x minus 1. So this line is, so now I have all my y's in terms of x, so I am just going to start coloring, but I'm going to color vertically. So watch, it's top minus bottom, so it's the line, x minus 1, let's set this up carefully, minus the green one. So be careful, what do I have to put in for this? What do I have to put in for the green one? Negative, yep, so I've got that. Now I have to adjust my limits, because the minute I get, and I'm coloring, it's getting kind of messy, but I'll start to do it. I'm line minus the green, all the way to right there, right? And that was at 2. So I actually have to adjust that, because after that, I'm no longer line minus green. I'm red minus green, or the curve minus itself. So let's go do that, and let's make sure we set it up right. From 2 to 3, I have to do the top part, which is the square root of 3 minus x, minus the bottom part. But the bottom part's negative, so what do I get when I do minus the minus? Plus, right? So I'm going to have plus. Do you see how messy this is? But if we do it right, we should get the same answer. It's the same blob of colored crud in here, whether I color this way or color that way. So let's go clean this up before we go to our calculator, because this is really messy. So I've got -1 to 2. I have x minus 1. Then I have plus root 3 minus x dx. That one's as good as it's going to get. You couldn't do that one by hand, by the way. Why not? Yeah, that inside function, boy, there's really, you can't. So this, but I'm just going to prove a point because I started it, that we should get the same thing unless I've made some little sign error here. Put one of these plus another one of these, I might as well write it as this. Now let's see how good you are at working your calculators, and go math 9 that. And see if it truly does give you 9/2. It should, unless I've made some sort of a sign error along the way, but I think we did a pretty good job of working it on out. Notice how much more eloquent the top one is. So although our go-to is to color vertically, sometimes the horizontal is the best way. And it's a pain to enter even. I don't know what you get. Should be the same. So you have to math 9 and then plus. Anyone done? What'd you get? 4.5. See, we got the same thing. And I would never do it this way. I kind of had you write it all down. I would almost, but if you do it right, they can all be done both ways. That's the moral to today's story. So I am done with that. What I'd